What up everybody? InstructaBeats back again here with another volume unit lesson. Today we're going to be finding the volume of a cone, just not this ice cream cone. So let's grab some chocolate syrup and a spoon and check out what our objective is today. Our objective today I will be able to demonstrate where the volume of a cone formula came from and be able to solve volume of a cone questions. But before we do that, we need to start with some math vocabulary. So the first thing we want to start with is the definition of a cylinder. It's going to be super important today. A cylinder is a geometric solid that has two circles for the base and top, and then the sides are perpendicular to the base, right? A cone is a three-dimensional shape that has a circular base and a side that tapers to the vertex. So you've seen a lot of different cones in your life. You might have seen traffic cones, right? And so this would be the vertex up here. This is my circle base, and it tapers, kind of angles off to that vertex. You might have seen an ice cream cone, just like we had on our title slide. And of course, we're probably talking about this math cone, which is not as exciting as ice cream, and probably more exciting than a traffic cone, depending on whether or not you're learning how to drive and getting your license. This is kind of the math cone that we're talking about. It has a circular base, and then sides that taper to the vertex right here. We need to understand the relationship between the cylinder and the cone, though, so that you really understand what's happening during this lesson. So here we have a cylinder, here we have a cone, and they have the exact same radius. Okay, so let's say it's 5 units. Okay, and this is also 5. All right, and then let's say it has the exact same height too. So let's say the height is 10, and then the height of this cone from the apex, kind of a curvy line, is going to be, there we go, 10. Okay, now if they have the same radius, if they have the same height, here's a very important concept, and it's kind of hard to see, but if I drag this cone over inside the cylinder, you might see what I'm talking about. Now what's really cool about this, and again we're assuming that the height and the radius are the same, and you can kind of see it here. A cone is exactly 1/3 of the cylinder. Okay, and that's of course only if they have the same height and radius. If you took a cone and you poured and you filled with water, okay, you filled the volume completely up, and then you poured it into the cylinder, it would take 3 of them, and you can kind of see right here. Now, you can kind of see maybe possibly like the other 2 cones right here. Okay, now it's not perfect because I'm not a perfect drawer, okay, but you can kind of see the outline of those cones. So a cone, again, assuming that the height and radius are the same, is 1/3 of the cylinder, and that is super important for this next slide. So we learned last lesson that to find the volume of a cylinder, you needed to figure out the area of the base and then multiply that by how many layers. And to figure out the area of the base of a circle, it was pi r squared, okay? But we just learned something really important. A cone is 1/3 of the cylinder. So if we want to find the volume of a cone, we can't use the volume formula for a cylinder. That doesn't make any sense. But what you can do is use the exact same formula, solve like you're finding the volume of a cylinder, but then you want 1/3 of it. You want 1/3 of the volume of the cylinder, right? Because a cone is 1/3 of a cylinder. Now, sometimes you also might see it written like this. It could be like pi r squared times height over 3. Sometimes the 3 is underneath the h. It's all the same thing. You're finding the volume of a cylinder, but then taking 1/3 of it because of that key thought. A cone is 1/3 of a cylinder.
Oh my goodness. Wow, that is so easy. I love that more than this ice cream cone.
So let's take a look at the steps for finding a volume of a cone. So here we have the same steps for finding the volume of a cylinder, right? Find the area of the base, find the height, how many layers of that are you going to need, and then you use the formula to solve, right? But that's a cylinder. If we wanted a cone, we would have to take 1/3 of that volume. So you find the volume, but then you're splitting it into thirds because you want to know the volume of the cone, not the entire cylinder. So you could either take the volume, divide by 3, or take 1/3 of the volume, because dividing by a whole number is the same thing as multiplying by the reciprocal. Again, all this math is interconnected, and we're taking what you learned in elementary school and now we're adding it and we're building on it for these concepts. So let's take a look at an I do problem. Okay, so here's my volume formula. It's going to be 1/3 of the area of the base times the height, because it can, again, area of the base times the height would be like finding the volume of the entire cylinder, right? If I drew that like that, but I only want to know 1/3 of it. So we don't draw it all the time because that would be ridiculous. So the volume is going to equal 1/3, right, times pi r squared, okay, because that's the area of the circle, times how many layers of that you have, right? So my volume is going to be 1/3 pi, my radius was 4, so 4 squared, and then I had 13.8 inches or 13.8 layers of that. So again, you can plug this in your calculator if you want and solve it that way, or you can take it one step at a time. It doesn't matter to me. So if I found the volume without taking the 1/3 first, okay, I'd be doing 1/3 of 693 and 312 thousandths. This is the volume if it was a cylinder, but again, I want only 1/3 of that because I'm doing a cone. So if I divide that by 3 or multiply it by 1/3, the volume of this cone is 231 and 104 thousandths inches cubed, or cubic inches. Okay, so if you understand where the volume formula for a right prism came from, and then where a volume formula for a cylinder came from, you understand this concept. You're just taking 1/3 of that formula. Let's do a you-try problem. Okay, so when you're ready, go ahead and pause the video. After I read the question, solve it, and then push play to check your mastery. So this is the height and radius of the cone below have a ratio of 4:2. All right. If the height is 15 feet, what is the volume of the cone? So I've added a little fun here to help you figure this out. So the ratio was 4:2. Okay, and height came first. So 4 is the height. Okay, so for every 4 inches of the height, there's 2 inches of the radius. So I could put height here and radius there. If that helps you, you know the height. Go ahead and figure out the radius and then plug that into the formula. Once you're done, push play to check your work. So the first thing I want to do is I want to find my unit ratio. Okay, so if I use my scale factor of 2, I know that for every 2 inches for the height, that is 1 inch for the radius. So my height is going to be twice as big as my radius. So if my height is 15, that means my radius is 7.5. And my height was 15. There you go. So now I'm just going to plug this into my volume formula. Again, I'm going to do 1/3 times pi r squared times how many layers that is. So I'm going to do 1/3, there we go, times pi. I know my radius was 7.5 squared times my height of 15, which is how many layers I have. I plug that into my calculator to solve it. And I know the volume, if this was a cylinder, the volume would have been 2,649 and 375 thousandths. But I only want 1/3 of that because that's a cone. So when I multiply that by 1/3, I get 883 and 125 thousandths feet cubed. So the volume of this cone is 883.125 feet cubed. So again, what we want you to take with you is the same thing from last lesson. Finding the volume starts with finding the area of the base. Okay. Our volume formulas all start with area of the base times the height, and then it might look completely different once you start manipulating it because you got to find the area in a different way. You might have to do 1/3 of what you actually want to find, okay? But it all starts with area of the base times the height. How many cubic inches or how many cubic units can fill up a 3-dimensional shape? Thank you so much for checks out today. We really appreciate it. We hope that you will like and subscribe. Leave a comment. Let us know where you're watching from. You can follow us on all our social media accounts. We really appreciate it. Thanks again. InstructaBeats out.